Alrighty, so there was a recent video I put out that happens to be how to design a rough draft prototype of my kinetic direction accelerator, inertial accelerator, and in real terms, truthfully, with a dampener, of course, that's going on to recapture. Yes, I have inertial dampening. Yes, even though I've never watched Star Trek, would love to meet some nerdy woman and get to watch that with them. Anyways, we're gonna move on. It's an energy recapture utilizing a spring is effectively what that would be, or there's a reduction of the given travel speed in a vacuum behind that it has to now fill with a given increased heat capacity from both the air and the heating up of the coils and the drop of energy from the magnet into the aluminum coil at the end. Okay. Now, it's a fairly simplistic rough draft design. All right. It does what it does. It's simple. But you know how to make it even better? So I never really talked about how to make electrostatics. I just sort of droned on a little bit about it, talked it up, all that. Because typically speaking, you got to do that to get someone interested. You know, give them that, yeah, I'm gonna do this shit. Yeah, that kind of thing. So, we're gonna talk about how to make this design better. All right, there's a way to use other magnets, permanent magnets, to increase and decrease flux in given areas by what I consider to be a lensing almost like effect. Now, if I happen to arrow shape it and cause it to spin in a given direction as it comes back, almost like a mushroom dip, truthfully, and same thing with the rear, to allow that occurring design, while allowing for a set of coils that is in line but with a electrostatic. In this instance, it would be kind of like a grid almost, but not like a grid. It's a bit weird. You need electrostatic fields to be in a very specific order to allow for the repulsive nature of the electromagnetic fields to be such that they grip in their directionality of spin for the flow of magnetic current, or not current, field, anyways, to be captured, squished, and directed out as it travels forward. Now, the reason why we're doing this is because it creates an electrostatic imprint onto the magnet's housing. That is right. But wait, why would you do this? If you don't know, because there's a vacuum behind and it got slowed down by an aluminum coil using eddy currents, and then I gained that heat back by utilizing that simplistic tube pump to capture some of the heat and then place it back into the cylinder. Because now it's a charge that happens to have a field, static charge field, like a capacitor, difference with magnets and coils that are so cleverly placed as to allow for it to recapture some of that energy. It now actually attracts backwards. Now, some of you might not understand quite where that ultimately is going. So let me describe this to you. Real sweet, like real easy and simple. As it travels forward, it then stops. Then you continue moving forward, but it's also attracted going that way. Thus, you get two kinetic accelerations imparted onto the housing of the tube that is possibly a part of your bike. As a result of that, you also get back that energy in the magnet capacitor now, alongside of extra energy from the heat that you may have lost and the heat from the outside of the housing added in. Once upon doing this, if you set it up in a proper rotational fashion, meaning oscillation from top down to bottom, bottom, or top down to bottom, in a near infinity-like design, you get a constant forward directional travel. Or you can simply use the rotational effect too, meaning top then bottom, top then bottom, top then bottom. Thus always netting you a positive forward thrust direction, while also allowing for you to resonate your gases. Using the spring as the gas, as it goes rearwards, it slows it down and helps add that given amount of thrust back forward as you are traveling, and dampening the inertia of the backwards traveling magnet. Good old inertial dampeners, right, folks? They somehow work. I don't know. Seems to work to me. Now, see, the difference between the static charge fields here and the material is very, very, very plainly put, extraordinarily simple. They are not just coils. They can't just be coils, unfortunately. You really do have to design them to project a electrostatic field, charge field, very precisely to hook into these magnetic fields correctly, to allow for it to collapse and situate itself on the surface area of this magnet. We're basically kind of creating a slight degree of ionic wind as it passes, and then a disruption of that ionic wind to creating current convections that allow for plasmification of the given air, gas inside. Now, the plasma only lasts for so long, and it will mostly, if shaped directly the correct way again, travel in a fashion that gets sucked and thrusted thusly in the direction that you wish for it to do so. Now, I think that's a bad idea, personally. I personally view this as a better idea, as a pump with no ionic real wind, utilizing a vacuum Stirling effect that creates the heat purely as a Jules Thomson style waste heat generator that I put up on my YouTube video before, to capture a larger degree of the atmospheric energy that we have going on, and a capture of the static and electromagnetic forces, and to help directionality wise here, because these are vague statements. You know, these are flux, curves, spins, corkscrews, charge fields, a whole bunch of large words that most people don't really understand unless they get into PhD physics. So, as a result of that, what I would say and state is that fields go burr real well. More electricity, keep it going for the battery used to allow for direction of movement from simple inertial impact driving forward by dampening inertial continuation in said direction you want to travel. Now, the reason why I don't like static charges for this given effect, this vast majority of what PhDs will say, is because static charges are extraordinarily, stupidly hard to make work. I go, you haven't heard of these things called linear accelerators on a chip. Electrons can still be used. Nothing says I can't use that. They have linear accelerators on a chip, like these little square fucking things that are circles. I mean, my electrons burr. And guess what? I get a static charge field. All I have to do is allow for it to be aimed with the correct quantum slot experimental geometric cut. And as they have a given charge on the surface area of the rear, and then the rest gets imparted as it spins and bell curves and blah, 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 blah. The big fancy word that basically means it produces a field of directionality that connects to the magnets. field, flux field. And it then goes into, you guessed it, little subtle imagery, a bunch of spin states that collapse any given kinetic directionality, which is like a big coil spring that is yanked really hard and pulls itself back in. Like a spring, otherwise known as a rubber band, otherwise known as anything else that does the I want to be in a different state thing that it usually is trying to do. I want to be entropically very even. You have cast me chaos. I hate you. And that's effectively what that is. So, as a result of this, given the reduction of cost as a result of the energy necessary, and a given, well, because this is a linear accelerator with pulses, and you could theoretically still introduce a degree of ionic and plasmification energy, you can decide to dump that as a battery. Or in this instance, wait for it, a capacitor battery electron flow circuit that has phasing DC to your electric motor, if you so decided to want one. Because why not? I never said that with the other video I put out. How the tic-tac cylinder design accelerated. Well, there's nothing saying I can't use the static, kinetic, and so on to introduce a directionality of thrust utilizing a near super fluid-like boundary layer by having the neutralization of the electron orbital fields, meaning their spin and so on. It's a little bit more directioned and spun and aligned and allowed to more evenly, with less resistance, flow across each other with less chaos, giving me a leg up in the competition for thrust in a given direction when I decide to have it flow faster and impart its kinetic Newtonian physics upon my tic-tac vehicle. Good old alien physics. Oh wait, no, that's still very much a thing that we know about. So why couldn't we do it with this? Nothing states I can't. Sure, it's a degree of energy, but if you get the right pulses and resonances and harmonics, the right extension of field as it travels along the given gaseous axes of connection, like chain links, traveling further out than the boundary layer would normally have you believe it could get to. Well, in fact, now I have a superfluid that extends quite far. Yes. In fact, I could probably put that on bikes. I could probably put that on planes. Probably put that on a lot of things. Ionic wind be damned. I'm using kinetic acceleration, not needing ionic. Why would I need ionic? Those are charge differences. I'm not looking for charge differences. I'm not looking for anything but imparting a given amount of kinetic potential in a highly organized directional manner that allows for me to gain an advantage that doesn't impart nearly as much exothermic reactivity whatsoever. Because why should I need it? I don't need exothermic. I don't need it to be chaos. Don't you understand? All exothermic kinetic is just chaotic kinetic direction. When all traveling together, it doesn't seem to impart much of any actual extra kinetic in a chaotic-like fashion, resulting in a seemingly thermal increase. If you do it perfectly, there should be nothing. Of course, you're not perfect, I'm not perfect, so there's going to be a degree of exothermic increase. But Can you get to that point? It's been seen in quantum physics already. I know it has. That's why I'm talking about it. Have fun.